Wanted to record a quick lesson on how to graph rational functions using concepts of limits. So I have a function f of x, which is a rational function. If we just look at the function without factoring the numerator and denominator, we see that right away we're going to have a horizontal asymptote at y equals 2. Leading coefficient, so the degree of the numerator is 2, degree of the denominator is 2. Therefore, the leading coefficient is 2 over 1, which gives us y equals 2. Now, that's from precalculus. In calculus, what we would say is the limit as x approaches infinity of f of x would equal 2. So if we go very far away from the origin, we end up with a value of 2, and we could also talk about it being negative infinity, but it would do the same thing going either direction. Okay, so horizontal asymptote taken care of. Next step, we probably want to factor that so that we can see where vertical asymptotes are and all kinds of fun things happen. So if we factor that top, we get 2 times the quantity x plus 3 times the quantity x minus 2 all over the quantity x minus 1 times the quantity x plus 2. Okay, so now that tells us our vertical asymptotes. Vertical asymptotes are determined by values that make the denominator equal to 0. So that would happen at x equals 1 and x equals negative 2. So I'm going to start to generate a bunch of information. Then we'll start to make a graph after we've pieced together a couple of these things. Okay, so horizontal asymptote, vertical asymptote, let's talk about x and y intercepts. Okay, x-intercepts first. X-intercepts occur when y equals 0, which is another way of saying what makes that numerator equal to 0. And so the numerator would be equal to 0 when x equals negative 3 and x equals 2. Y-intercepts, staying with that same concept, y-intercepts happen when x equals 0. So when we plug 0 in for x, we would get on the top 2 times 3 times negative 2, which would be negative 12. And on the bottom, we would get negative 2, which gives us a y-intercept of 6. Okay, so we can start to put that together into a graph, and we're going to base that graph off of the information that we can currently work with. Now, later on, we're going to learn some things in calculus that are going to allow us to make even a more accurate graph, but for now, we're going to kind of take a pre-calc approach to this. So let me move my axes here. Okay, we got that. All right, and then we'll start doing some asymptotes. So we'll make our asymptotes orange for no particular reason. All right, so we've got a vertical asymptote at 2. Horizontal asymptote at 2. So we'll make this value 2. It's a little hard to see there. So we'll switch over here, make that. We'll go by values of 2 here. So this will be 2, this will be 2. Negative 2, negative 2. Okay. And then we've got vertical asymptotes at 1. And negative 2. Okay. And then, what else do we know? So other information, we have x-intercepts at negative 3. Going to cross there, and at 2, and a y-intercept at 6, which would put it all the way up 2, 4, 6, up here somewhere. Okay, so now we need to figure out, and technically speaking, we should have arrowheads on these. We need to figure out the behavior then around each of these asymptotes. So we know that it's not going to cross a horizontal asymptote and we know that, it can cross a horizontal asymptote. It won't cross a vertical asymptote. So it might do some funky things around the horizontal asymptote, but for the most part, it ends as a guide. So if it's going to pass through this point here, then we know that it's going to have probably curve down this way. Okay? But we don't know for sure. Well, how can we figure it out? We can look then at the limit as x approaches -2 from the negative side of the function. Okay, so if I go back to the original function, what happens if I put a number a little bit smaller than -2? So if I put in, let's say, -2.1. If I put -2.1 in here, that number is going to stay positive because it's a number. -2.1 here will give me a negative number. -2.1 there will give me a positive number. This will be negative. This will be negative. So we have a negative. 2 negatives on the bottom would make a positive. 1 negative on the top gives us a negative or a positive, which means that this would be -infinity. And so I was right. That curves there. And then it's going to stay close to that horizontal asymptote as it curves in that direction. Using that same idea, if we look at the far end of the graph, the far right side, my guess is that it's probably going to do something like this, passing through that x-intercept and curving down. But again, from calculus, we can verify that and say, what is the limit as x approaches 2 from the positive side of f of x? Okay, so we get rid of all these little markings from before and do it all over again. If we look at a number a little bit bigger than 2, so like 2.1. So I put 2.1 in, positive, 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 positive. And I screwed up somewhere. A little bit. Oh, that's because I'm not at 2. I'm a little bit bigger than 1. So let me fix that. Good thing I'm recording this. Okay, so my asymptote is at 1, not at 2. So I'm something like 1.1. So if I put in 1.1, positive, positive, there's my negative, positive, positive. So a negative over a positive would, in fact, give me a -infinity there. Okay. Now we got to figure out what happens in the middle. So in the middle, we traditionally see one of two shapes, either that tangent-looking shape or a parabola-looking thing. And how are we going to do this? Well, there's a pretty good chance that the center portion is not an inverted parabola because it would cross the horizontal asymptote. It also wouldn't do that because we would know that in this region here, we would have another x-intercept, which we know doesn't happen. So my guess is that this is going to be a parabola going like that. But we can test that by, again, looking at the values from calculus and looking at some limits here. So I want to look at the limit as x approaches -2 from the positive side of this function. Okay, so we get rid of our old marks. And we say, okay, let's look at a number a little bit bigger than -2. So let's say -1.9. Still positive here. Still positive. Negative. -1.9 would be negative and positive. So a negative over a negative is positive, which confirms that this goes to infinity. And therefore, the left-hand side would, in fact, curve up along that asymptote. And then the last one would be the limit as x approaches 1 from the negative side of the function. So we're looking at this region here. Okay, so if I look at that region there, I want a number a little bit smaller than 1, let's say 0.9. So if I put 0.9 into this function, I would get a positive, a negative, and a positive. Negative over negative is positive, and in fact this goes to infinity. Okay. Now we don't necessarily know, let's talk a little bit about this point here. We don't necessarily know that that's the bottom of that parabola looking thing. It's just some point we use at reference. Right now, we don't have enough information to get an extremely accurate vision of what that little parabola-looking thing in the center does. But over time, when we do some more work with derivatives and things like that, we'll be able to make a very accurate graph, a much more accurate graph than what we would have been able to do in precalculus. So hopefully this helps some ideas of how to use the calculus concepts of vertical, horizontal asymptotes, and in particular limits to create fairly accurate graphs of rational functions.